As with the previous video, this one's totally optional, but I'm going to walk through that demo for the left-leaning red-black tree. So I would really recommend that you actually try and do this on your own. It could be a little tedious maybe, but at the very least, maybe pause this video as I walk through the demo and see what's going on. So when we insert 7, we just have a node, and so here's my left-leaning red-black tree, and here's my 2-3 tree equivalent. Now when I add 6, I end up with this left-leaning red-black tree corresponding, as you might imagine, to the simple 3 node, which contains 6 and 7. Now where things get interesting is when we insert 5. So when we insert 5, we get a left-leaning red-black tree, which has 2 consecutive left links. This represents a temporary 4 node, and so what we need to do, as we see up top, is rotate to the right. In particular, we need to rotate 7 to the right, because we want 6 to be the new root. So when we do that, we end up with 6 as the new root, 5 and 7 below, and at this point, we need to fix the fact that we have a red left and a red right child, and in that case, we will do a color flip. Okay. So here, this add operation, we do a rotation and a color flip, and we end up with the equivalent of this 2-3 tree below. Next up is adding 4. Adding 4 isn't very interesting. We just dangle it off of the 5 in the red-black tree, and that corresponds to this 2-3 tree below. Now when we add 3, okay, well now we have a problem, because we end up with a misrepresented temporary 4 node that we're going to need to put into the correct configuration and then ultimately do a color flip so that we can emulate the process of splitting. So because we have an invalid 4 node representation, we're going to rotate to the right as we did earlier. And when we rotate 5 to the right, we get this better representation of a 4 node. At this point, we do a color flip and we end up with, the 2-3 tree. Okay. So by maintaining the one-to-one correspondence, we have achieved something great. Let's keep going. 2, not very interesting. Okay, that just means stuffing another item into this 2 node down here, yielding a 3 node. And so in our left-leaning red-black tree, we end up with, okay, there's a 2 hanging off with a red link. And now the final operation is going to be fairly interesting. So when we add 1, okay, in 2-3 tree world, that means that we end up with a temporary 4 node, that splits, 2 goes into the root. Well now the root is itself a temporary 4 node, so we split that, and we end up with a perfectly balanced tree. How is that going to happen in left-leaning red-black tree? Well, we're just going to copy the same behavior. We're going to maintain this this one-to-one mapping, and everything will work out fine. So we add 1, and now we see that we have 2 consecutive left links. Not so great. Okay, so what we do now is we need to change this so that we have a proper representation of a 4 node. So to do that, we rotate right on 3, and we end up with, again, this nicer 4 node representation. Perhaps we're starting to see a pattern. Okay, we need to do a color flip to emulate this splitting operation, because right now, this tree shown is the equivalent of the second state of the 2-3 tree. After doing a color flip, we end up having this right here. So right here, if you look at what we have, effectively is a bad representation of the 2-4-6 4 node. So this 2 consecutive left link means we need to do another rotation. So starting from where we were and performing some operations, I'm just going to copy and paste this because we don't have enough room. So we're going to continue where we left off right here. And the next step is we're going to rotate right. And so basically what we're trying to do is, this is a bad representation of this temporary 4 node. By doing a rotate right on 6, we get to a good representation. And here you can see, hey, our tree is balanced. The last step we need to do is a color flip on 4, and we end up with, ultimately, our binary search tree that is exactly the same as this 2-3 tree, and is therefore balanced. Now this example that I showed, I was only having consecutive left links and having to do color flips. And so if you want to exercise all of the rules, it's a little more tedious, but what you can do is try inserting the numbers 1 through 7 in increasing order and see what happens. But there you have it. All we basically did is we copied everything that a 2-3 tree does, and in response to that mimicry, we end up getting this nice, beautiful, wonderfully bushy tree with only a few simple rules.